Hello friends, subscribers and new viewers of this channel, and welcome to the computer vision tutorials. In this video, we provide a detailed tutorial on how to install and use Meta's Segment Anything Model 2.1 or SAM 2.1 in Python and Windows. SAM 2.1 is a very powerful computer vision model and algorithm that can be used in a number of applications. Over here you can see a brief demonstration of SAM 2.1. Namely, on the right side you can see the original video that I filmed near the place I live. This is a real wild coyote that I often see around my apartment. He doesn't attack humans, however, he definitely likes to hunt rabbits and rats. Sometimes he might even get a duck or even a cat. This coyote video is often used as a test video on my channel. The goal of the computer vision algorithm, that is the goal of SAM 2.1, is to track this coyote in the video. To track this coyote, we need to isolate a single frame and to stop a single frame and to find the coordinates of 2 points on the body of the coyote. By only using these 2 points and the information about the frames, SAM2 model and algorithm is able to mask the coyote and to automatically segment its shape and to track the coyote in the video. And over here you can see the result. Coyote is colored by using orange color. This is actually a mask that is used to distinguish coyote from the background. That is, the body of the coyote is clearly segmented and distinguished from the environment, and we can get the coordinates of any point of the body of the coyote. I'm really positively surprised by the power and the performance of SAM 2.1 algorithm. This algorithm might have a number of interesting applications in robotics that we will explore in our future video tutorials. We can even extract a center of the mass of coyote body, or we can use any other point. We can even design a Kalman filter and a predictor for tracking the center of the mass. In this tutorial, we explain all the steps you need to perform in order to install and use SAM 2.1. Before we start with explanations, here are very important notes. First of all, the installation process might be a bit tricky since this software is mainly developed in Linux and for Linux users. On the official GitHub page of SAM 2 and SAM 2.1, it's suggested to use the Windows Subsystem for Linux or WSL to run the software in Windows. However, experience shows that this is not a good idea. This is mainly because WSL has a number of graphical issues and it's not good for running graphical applications. In contrast, in this tutorial we explain how to correctly install SAM 2.1 directly on Windows. We then explain how to write a Python program for using SAM 2.1, and the Python program is given over here. It contains around 150 lines of code, and we will thoroughly explain how to write this program in this video tutorial. Note that if you blindly use the installation instructions and code given on the official SAM 2.1 website, you might get a number of errors and you might not be able to use it on Windows machines. This is mainly because these instructions are valid for Linux machines. In contrast, we explain how to install SAM 2.1 and how to write a Python code that can be executed on Windows machines. You can easily upgrade and modify the code that we will explain, and you can add additional functionalities. We provide links to this installation manual, Python code, and demo Coyote video used in this tutorial. Links are given in the description below this video. That is, we provide everything necessary to run SAM 2.1 demo presented in this tutorial. Before you start with the installation process, it's very important that you have the necessary software and hardware prerequisites. First of all, you need to have a relatively new GPU. We have NVIDIA 3090 GPU with 24 GB RAM. We also tried NVIDIA 2060 Super, and the computation is at least 4 to 5 times slower compared to the computations performed by using NVIDIA 3090. Then, you need to install several programs. First of all, you need to install Microsoft Visual Studio C++ 2022 Community Edition. You will get a C++ compiler with this program. Note that this program is not WS Code. To download and install Visual Studio 2022 Community Edition, you need to go to this website over here. Then you need to select the Community Edition. The Community Edition is completely free and you don't need to pay for the license. After you click over here, the download process will start and you need to run this file that's being downloaded. After that, it might take maybe 15 to 20 minutes to install Microsoft Visual compilers. And this is a very important step. We need this program to make sure that PyTorch will have the necessary DLL files. We notice that in normal Python virtual environments there are errors if Visual Studio C++ compiler is not installed. Also, there are known compatibility issues between older versions of Visual Studio and older CUDA toolkit versions. For example, there are compatibility issues between Visual Studio 17.10.5 and CUDA toolkit version 11.8 and 12.1, and probably there are other compatibility issues between different versions of Microsoft Visual Studio and CUDA. Consequently, make sure that you install the newest version of Visual Studio C++ and CUDA, and we will explain the CUDA installation process later on. In our case, we installed Visual Studio C++ 17.11.5 and CUDA Toolkit 12.6. This combination works. In any case, if you experience errors, install Visual Studio C++ 17.11.5 and CUDA Toolkit version 12.6. Other combinations might also work, and it's up to you to test different versions. Then, you need to install NVIDIA CUDA Toolkit from the official webpage. Both CUDA Toolkit and PyTorch should be installed separately. To install CUDA Toolkit, you need to go to this website over here. And since this video is made in October 2024, the current version of CUDA Toolkit is 12.6. However, we have also noticed that SAM2.1 works with older versions of CUDA Toolkit. For example, it works with CUDA Toolkit 12.2, 12.3, 12.4, etc. However, if you install some older version, and if you, for example, install some other Visual Studio C++ version, there might be some compatibility issues. So consequently, try to investigate what matches what. In our case, CUDA Toolkit 12.6 completely matches the Visual Studio or Microsoft Visual Studio C++ compiler. Then, after you install NVIDIA CUDA Toolkit, you need to do several checks. First of all, you have to make sure that CUDA Toolkit is in your system path. To check that, click here and search for Edit System Environment Variables, and this screen will pop up. Over here, you need to set this environment, CUDA Home, and this should be the path to the installation folder of CUDA Toolkit, and here it is. Then, system variables have to contain CUDA path, which again should point to this folder over here. And you should have this additional variable, CUDA path version 12_6. So make sure that these environment variables are added to your path and they can be recognized from the command prompt. We will explain this later on in this tutorial. Then, you need to install FFmpeg command line audio video tool for extracting images and frames from your videos. In fact, we created a video tutorial on how to do that. And here is the video tutorial. You can also find this video tutorial on my YouTube channel, and here's the video tutorial. This video tutorial will lead you and will explain all the steps that you need to perform in order to install FFmpeg. Or if you would like to do it by yourself and to investigate how to do that, you can go to this website, then you can search for your Windows version, and you can from there install and then add the installation folder to the system path. In my case, if I again search for environment variables, and if I click here on environment variables, in my system path there is actually a path to the FFmpeg. So if I double click here, you will see a folder over here that contains the path to the FFmpeg, that is to the binary folder. Consequently, you also need to do that, and the tutorial given over here explains how to do that. Then you need to install Git and Git support for large files. You will need Git since you will download or clone the remote SAM2.1 repository. Consequently, you need to install Git from the official web page. So go over here and download the proper version for Windows. In my case, this is the version. However, the story doesn't end there. You will also need Git support for large files. And to install that support, after installing Git, you need to go over here and from this website to download the Git support for large scale or large files. Then you need to have the VLC media player installed. You need this player since sometimes the default Windows media player cannot play the videos generated by using the FFmpeg or FFmpeg. To download and install the VLC media player, you need to go to the official website and you need to download and to follow the installation instructions. Optionally, you can also install Visual Studio Code for editing Python files. However, you can also use some other Python editor to edit and execute Python files. If you want to install Visual Studio Code, you can use my tutorial given over here, or you can just go to the download web page and you can download it. And finally, you of course need to have Python installed on your system. Let us double check everything and let's make sure that we have all the software installed on our system. First of all, I'm going to open a command prompt by clicking on Start and searching for command prompt. And over here, I will start first of all verifying the Python installation. To verify the Python installation, I need to type Python and then version. And you can see that I have Python version 3.12.4. However, some other Python versions will also work. I'm not 100% sure, however, I think that the requirement is that the Python version is above 3.10. However, my suggestion is to always try to install the newer version of Python. Then, let's verify that CUDA is properly installed. To do that, we need to type nvcc and then version, and this will verify the NVIDIA CUDA compiler driver, and you can see that I'm having this build, CUDA 12.6. Next, let's verify that FFmpeg is actually installed and that it's in the system path. To do that, let's type this, and as the output you should see something like this. This means that FFmpeg is installed. Then let's make sure that Git is installed and that is in the system path. It is. Next, let's one more time verify that CUDA home, CUDA path, and CUDA path version 12.6 are in my system path. To do that, again, click here and search for edit the system environment variables. Click here. Again, you need CUDA home, then you need CUDA path and CUDA path version 12.6 or any CUDA version that you installed. Okay, let's start with installation procedure. In the first step, we need to clone, or better to say to download, SAM2.1 from the online repository as well as some other files. For that purpose, let's open a command prompt. And over here, I'm going to resize this command prompt such that you can see what I'm typing, and at the same time, you can follow the manual given over here if you don't see or if you cannot recognize what I'm typing over here. The commands will be given also here. First of all, let's go to the base C drive, and over here, let's create a folder for our project. I'm going to call this folder as SAM2.1. Consequently, let's navigate to this newly created folder, and inside of this folder we need to clone this remote repository. This remote repository contains several things. However, it doesn't contain all the files, or better to say all the checkpoint files that you need to download. So let's go to this repository, and first of all, make sure that you understand the following. In this video tutorial, I'm explaining how to install the newest version of SAM, and that's SAM 2.1 version. However, there is also an older version of SAM, which is SAM 2. In any case, the main branch of this remote repository will actually contain the newest version of SAM, and consequently we will download the main repository. Now, another thing to keep in mind is that this repository does not contain the checkpoint files. That is, it doesn't contain all the model files. And later on, we will download these model files from some other website. Okay, so let's go back to our manual. And inside of this folder, we need to type this command, git clone. And we are cloning over here the main branch, which is the branch that contains 2.1. Maybe in the future, if you're watching this video tutorial, for example, in 2025, a newer version of SAM 2 appear. For example, SAM 2.2, SAM 2.3, or a similar version. However, the installation procedure should be the same. Maybe the code will be slightly changed depending if they change something in a code, or if they integrate some other functionalities, or if they fix some bugs. However, generally speaking, everything should be the same, at least in principle. So let's clone this remote repository, and this will take some time. Now be patient over here. Okay, here it is. Now, if you type this command, you will see that this new folder is created, and this folder contains everything. So let's navigate to this folder, and let's see its structure. Here it is. Good. Then we need to download the necessary model checkpoints. Since we are on the Windows machine, the official instructions will not work. Namely, on the official web page, it's suggested to run a script inside of the checkpoints file. However, if you try to run this script on a Windows machine, you will fail. However, here is the cure for that. We don't need to run this script. We can actually manually download all the files whose links are given in this script. And here it requires for you a little bit of Python knowledge. However, don't worry, I will explain everything. First of all, let's start Visual Studio Code in this folder. And over here, I'm going to open a file. In the checkpoints, there is this script over here. And if you carefully analyze this file, you will see several interesting things. Over here, you will see the path to the files that you need to download. Now, these files are given actually over here. And what is important to observe is that here's the base URL, or the base address, And on top of that, you can see the files that need to be downloaded. Here's the first, second, third, and fourth. And these are the model checkpoints files that should be downloaded, and then they should be copied to this checkpoints folder. And that's exactly what the script is doing. So we can do it manually. To save your time, over here, I copied the complete path to these model checkpoints. You can do it actually manually. Namely, you can simply copy this base path and on top of that add the particular model or the checkpoint file, and you will get the complete path. And then you simply need to go to web browser, you need to paste this thing, and the download process will automatically start. However, I'm going to do it over here. Since I already prepared the complete links, I'm going to copy this link. Then I'm going to go over here to my web browser. I'm going to paste this link. And after I press enter, over here you can see that the download process will start. The first checkpoint file is not large. It's only around 150 megabytes. And after we are done, let's open the downloads folder, and here it is. Here's the first file. Before we copy them to the corresponding folder, let's download the 3 other files. So let's do it again. Here's the second file, or the checkpoint file. Copy this one, paste here, press enter, the download process will start. And let's make sure that the file is over here, it is. And let's do it for the 2 other files. This is the third one. Simply copy this, go here, paste. The third one will be downloaded. And let's download the 4th file. Here it is. Copy, paste over here, and the download process will start. Again, I think that the last file is a bit larger. It's around 156 megabytes. I will explain the purpose of these model checkpoint files later on in this video tutorial. Now that we have downloaded all 4 files, let's go to the download folder. Let's simply select the file, let's copy them, then let's go to our C drive, SAM2.1. Let's go to this folder and let's copy these files to this checkpoints folder. And here they are. Beautiful. In the next step, we need to create a Python virtual environment, we need to install packages and build everything. So let's start from scratch. I always like to do that. Close this terminal and open a new terminal. This video tutorial is made for people who don't know a lot of things about Python or installing software and by running Python code. Consequently, I will spend some more time explaining some basic steps. First of all, let's go back to the C drive and let's go back to our SAM2.1. Then inside over here, let's navigate to our SAM2 folder, and here are all the files. In this folder, we need to create and activate our virtual environment. To do that, we need to type Python with an option M, then we need to call venv command, and we need to specify the environment name. I will call the environment 1. Some viewers of this channel often ask me, why do I need to create a Python virtual environment? Well, the reason is very simple. By creating a Python virtual environment, you will have complete control of all the packages as well as the package versions that are installed in your Python environment. That is, your Python virtual environment is Python environment created from zero. And you will not have conflicts with older software versions, and you will be able to create a clean environment for the development of your software. The next step is to execute this activate.bat file inside of the folder environment1 scripts, and this will activate your environment. And the indication that your environment is activated is and one inside of parentheses over here. Okay, let us start with installation of packages. Now, before you even try to install anything, it's very important to read this setup.py file. A lot of users are simply and blindly running pip install, and then at the end that they cannot install anything because there are certain version conflicts. So let's open the file setup.py. If you go back to the Visual Studio Code and if you click on open file, here we need to find setup.py, and let's see what's written over here. You can see everything that's written over here. You can see the required dependencies, and this is very important. Torch should be greater than or equal to 2.3.1. That is, this is the version that we need. The same thing with Torch Vision, the same thing with NumPy, the same thing with TQDM, HydraCore, IOPath, Pillow, etc. So these are the base packages, and here are the extra packages that we will actually not use in this video tutorial. And these packages are also not necessary since we are not running an interactive demo, and we are also not running the development version. Here are some additional things that are very important. Over here, you can see that build CUDA is being searched for, and some other very important parameters are being set. If you further read, you will see what is being compiled over here. That is, we are not simply downloading the files, something is also being compiled and built locally. So spend some time if you want to learn more about Python studying this code. Luckily, I created this video tutorial that will help you to install everything with no problems, even if you don't understand what's written over here. First of all, let's make sure that we can recognize the NVIDIA CUDA compiler, and to do that we need to type this, and you should see this output. Then you need to execute this command to make sure that CUDA home can also be seen. That is, that this environment variable will point to this folder over here. The first thing that you need to install is setup tools. So let's run this command. Pip install setup tools. Oops, this is not what I want. I need to type pip install setup tools, and let's press enter. Now setup tools will be installed. This might take a few seconds. Next, we need to install PyTorch, and this is a very critical step, and you need to perform this step correctly. To properly install PyTorch, you need to go to this website over here. So let's go to the website, and on this website you will see this selection table. Click here to select the stable version, click here to select Windows, click here to select pip or pipe, click here to select Python, and over here click on CUDA 12.4. Note that this PyTorch CUDA version slightly differs in version from my CUDA 12.6. However, this is not a big issue, and CUDA PyTorch 12.4 will work with the CUDA compiler 12.6. At least I didn't see any issues. However, be aware of these versions differences. And after you select everything, this command will be generated. So let's execute this command inside of our prompt. And here it is. This command will install PyTorch, Torch Vision, and Torch Audio. Now, usually it might take even 5 minutes to install PyTorch since PyTorch is extremely large. In my case, it's going to take less, mainly because PyTorch is already cached somewhere in a pip memory. Consequently, I'm not actually downloading PyTorch from online repository. I'm actually using the cached version. This is because I often install and uninstall different environments. However, first time you try to download, it's really going to take even 5 to 10 minutes. Then we need to install matplotlib. We can do it like this. And here it is. This is going to take maybe 30 seconds maximum, depending on how fast is your internet connection. And finally, after all these steps, we can run pip install with an option A and dot. This will actually run the setup.py file, and this will perform the complete build of SAM2.1. So let's execute this and let's hope that we will not see any rare errors. Now again, this is going to take a while, maybe even 2 to 3 minutes. Behind the scenes, the setup.py file is being executed and all these installation options are being checked and everything is being compiled. So let's be patient and let's wait a little bit. After several minutes, the complete build process will be completed, and then scroll all the way up and you shouldn't see any error. In the next step, we need to extract images from videos. First of all, you need to create a folder for the source video and the source images. Make sure that you're in the base folder and then create a folder called video. Then, let's navigate to this folder. You need to copy the video file to this folder. In my case, I will be using my beautiful Coyote video. Here it is. So I will simply copy this video and I'm going to paste this video inside of the newly created folder. So I will go to SAM2.1, SAM2, and over here I will go to video and I will simply paste the file. And here is the video. I reduced the frame size of this video to 15 frames per second in order to reduce the number of images. In your case, if you don't want to use this video, you can use any other videos you have. For example, you can film yourself how you walk, or you can film a ball that's being thrown or something similar. My advice is not to make the video to be longer than several seconds, and try to compress this video to be, for example, 15 or 20 frames per second. Of course, this software can handle videos that last for hours, however, it's going to take probably a day to process the complete video. Since this is an intro tutorial and you're learning how to use the software, use short videos. Okay, so let's go back to the terminal and let's make sure that the video is over here. The next step is to use the FFmpeg to extract frames from this video. And this is a very important step. Namely, SAM2.1 doesn't work with MP4 videos. You need to decompose or to extract frames from your videos. And to do that, I will run this command. This command will call FFmpeg. Then it will specify the input video name, video1.mp4. Then over here I'm having this simple parameter, and I need to specify the start number. The start number of the frame will be 0, and over here I'm specifying how my frames will be formatted. You will see this formatting option later on and the effect of this formatting option. And if I press enter, here it is. Now scroll way up and see if there are some errors. Over here there are no errors. Now if you type this command, you will see all the frames that are extracted from the video. And let's see these frames over here. We are in the SAM2 video and here are the frames. Here's the first frame, my Coyote, the second one of the Coyote, and the last frame of the Coyote inside of this video. Good. The SAM2 algorithm works like this. It will take all the frames and it will process the frames frame by frame, and it's going to create a series of images out of these frames, and these processed images will be stored somewhere else. Then we will glue all these images together to create our new video. Consequently, we need to create a folder for the frames that will be generated by SAM2. For that purpose, let's go back to the terminal, make sure that you're in the SAM2 folder and not in the video folder, and over here create a new folder called output. And over here go to the output folder, and in this folder we will store everything. So let's go back to the SAM2 folder, and the next step is to create our code and to run the code. In the sequel, we present a Python code that demonstrates how to use SAM2.1. However, before we do that, make sure that all Visual Studio Code sessions are closed. And we are going to start Visual Studio Code from our virtual environment. By doing so, Visual Studio Code will be able to automatically recognize our virtual environment. To start Visual Studio Code from the virtual environment, make sure that you're in the base folder and run this command. And here it is. Over here, I'm going to create a new file. Here, click on File, New File, and I'm going to call the file as test1.py. Here it is. And let's save this file in the base folder. That is, the file should be in the base folder of your SAM2.1. This is very important. And over here, to save time, I'm simply going to paste the content of the file, and I'm going to explain this file line by line. First of all, we need to import the necessary libraries. We are importing OS, since we are going to combine paths. Here is PyTorch, here is NumPy, here is matplotlib.pyplot. Here we are importing Pillow, and we are going to use images from Pillow. Then from SAM2 build_SAM, we importing build SAM2 video predictor, and we importing also input output. Over here, we need to write a piece of code that will automatically select GPU or CPU. To do that, we're simply asking if torch.CUDA is available. If yes, then set the device to be CUDA, otherwise set the device to be CPU. This piece of code will automatically select CPU or CUDA, that is your GPU, if you have GPU installed on your system. Again, my suggestion is to run this code by using a GPU. And if you have NVIDIA installed on your system, device will be CUDA. And over here, we are setting the data type in PyTorch for computation. To speed up the computations, we are using bfloat16. That is, we are using floats with 16 bits. And we do it over here. Over here, we need to select our model, or better to say, the checkpoint of our model. The checkpoint stores all the model parameters and everything that you need in order to run SAM2.1. If you remember at the beginning of this video tutorial, we downloaded all the model files, that is all the checkpoints, and we store them over here. Consequently, we need to select one of these checkpoints from this folder. And that's precisely what's happening over here. Over here, in order to help you, I listed all the checkpoints. Here, you need to specify the absolute path to the model file. When specifying the absolute path to our model file, it's very important to keep in mind the following. Open a terminal and let's navigate to the checkpoints folder. And let's compare this path over here and the path written over here. What is the difference? The difference is that in Python we are using double backslash to specify the path. That is, in the terminal you will see a single backslash. However, in Python you need to specify a double backslash. And to summarize, to select the model, over here you need to provide the absolute path to this folder. And in addition to this, you need to specify the name of the file. And all the files are over here. To help you, I have written the names of the files in my Python file. However, besides specifying the checkpoint file, we also need to specify the configuration files. And here are all the configuration files that exist. Every of these configuration files corresponds to a particular model file. For example, this SAM2.1 here, a large checkpoint file, has an equivalent in the configuration file, and here's the corresponding configuration file. Here we need to specify the absolute path to the particular configuration file. Since I'm using SAM2.1 here a large, I need to specify SAM2.1 here a large.yml. All the configuration files are located over here. So let's go to that folder. Namely, inside of SAM2, there is another folder, SAM2, then we have the configuration folder, and in this configuration folder we have configuration files for particular versions of SAM. This is the folder for SAM2, and this is the folder for SAM2.1. Since we are using SAM2.1, let's navigate to this folder, and here are all the files. You can see the path over here. Let me copy. And over here, just in the comments, I'm going to paste this path over here. And you can see the difference. Again, instead of a single backslash, we are using a double backslash. And you can see all the files over here. In particular, we are using this file, so let's look into its properties, and let's copy, for example, its name, and let's make sure that this name completely matches the name specified over here. And we can see that this name matches this name. Good. Next, we need to create the predictor object, and we do it like this. We declare predictor to be the output of the function build SAM2 video predictor, and to this function we pass two input parameters. The first input parameter is the absolute path to the configuration file. That is, we pass this path, and the second input parameter is the absolute path to the model checkpoint file. That is the path to this file, and over here we set device to be equal to device. In our case, device is GPU, since over here this piece of code will automatically select CUDA, that is, it is going to select our GPU. Next, we need to define the mask function. Here's how we do it. We specify the input parameter, the mask object, the axis object. Over here we specify the object ID, and we specify this Boolean variable for random color. If random color is true, then we create a random color. Otherwise, over here we specify the corresponding color. Then over here we get the mask parameter, we define, or better to say declare, the mask image, and we show the mask image. Here's the function for showing points. This function will be used to show the points. We pass the coordinates, the labels, the axis, and the marker size. Over here we get the positive points, negative points. Over here we use the scatter to get and to plot the points. You can see how we do it. And we use that for the positive points, and over here for the negative points. Simple as that. Later on, I will explain how to use this function. Next, we need to specify the path to the input video folder. In our case, the input video folder is given over here. Consequently, let me just copy this path such that you can see the difference. Consequently, over here, we need to modify this path by adding double backslash, and that's it. And again, SAM2 algorithm doesn't work on the video. It works on the extracted images that are given over here. Consequently, we need to specify the absolute path to the folder storing these images. After that, we collect all the frame names or the names of all the files and store them inside of this list called frame names, and then we sort them by using the lambda function. And here is one very important thing that we need to explain. Now, over here, I will select the index of the frame for detecting my object. Namely, I'm going to use the first image or the frame index 0, that is this particular image, and on this image I'm going to manually locate the coordinates of 2 points belonging to the body of the coyote. Later on, I will insert these 2 points in my code, and only on the basis of these 2 points and other frames, that is other images, SAM2 algorithm will be able to automatically recognize the coyote and to mask its area. Okay, so type this part over here. This piece of code will open the image and it will display the image. And after that, I'm going to stop the code and the user will have to press enter to continue. So let's run the code until here and let me explain you how to get the points. To run this code, we need to do the following. First of all, we need to press and hold Ctrl-Shift-P to select the Python interpreter. Click over here. Again, to get to that menu, you need to press and hold Ctrl-Shift and then P. Over here, you need to select the correct Python interpreter. Namely, we need to select the Python interpreter that is inside of our virtual environment. And over here, you can see that Visual Studio Code is smart enough to recognize our Python executable inside of our environment. So let's click here, and after we click there, we can run this code by clicking here. And let's wait until the image is being loaded. Here it is. Here is our image, and the frame number is 0. Now, as I move my mouse cursor over here, in this corner you will see the coordinates of points. So if I move, you see how the coordinates change. Find the first point on the coyote body. Over here, since this is an intro tutorial, I didn't code to automatically detect these points, so I will manually press these points and find these points. So for example, the first point is given over here. It is 2749155. Okay, so this is the first point, and I need another point. So for example, a point over here. Another point is 27061212. Good. So let's use these 2 points and let's insert them in the code. Now, over here, if I close this frame, you will see here, press enter to continue. I will press enter, however, you need to press enter inside of this terminal, and the code will continue. However, I will press Ctrl-C to stop the code. Now, we executed the code until here, and I explained every line until here. Now, I'm going to skip few lines, and I'm going to explain these lines that I skipped later on. However, over here, I need to enter the points. So the first point is 2749, and another coordinate is 1155, and the next one is 27061212. Okay, so here are the 2 points. Of course, you can select more points. Now let me explain why we are doing this. First of all, after this code block, we need to initialize and reset the state. We do it like this. Then over here, we need to specify the index of the frame we interacted with. It's index 0, and we need to give an ID to the object we interacted with. I will call the object 1. That is, this is our coyote. Over here, we need to define the matrix containing the coordinates of the object. That is the 2 points of the object body. Here I filled in this matrix. Then we need to specify the labels. Label 1 over here means positive click and 0 means negative click. Since both of my points over here are positive points, I will have 1 and 1 over here, and I need to specify data type. After that, I need to call predictor.addNewPoints, and I need to register my points. I need to specify the inference state, which is actually declared over here. I need to specify the frame index. The frame index is 0. I need to specify the object ID. My object ID is 1. I need to pass this matrix containing the points, and I need to specify the labels. Now, this is all SAM2.1 needs. It's going to take these points into account, it's going to do computations, and it's going to properly segment that coyote. In the future video, it's going to be able to propagate this segmentation and to properly segment our coyote in future video frames. Over here, for double checking everything, we are showing the result on the current frame. That is, we are simply going to denote the points that we just selected, and we are also going to show the mask to make sure that SAM2.1 was able to correctly recognize our system. That is, to correctly recognize everything and correctly segment our object. And after showing the result on the current frame, that is showing the mask and showing the points, we need to put this part such that the user can verify the results and can inspect the image, and if the image is okay, we will continue further. If the image is not okay, we will still continue. However, we can press Ctrl+C to block the code, that is to stop the code. So let's execute everything until here. Okay. The purpose of this second run of the code is to make sure that these points are properly being selected and that SAM2.1 was able to correctly mask everything. So let's run again and let's see what happens. Okay, so this is the original image for selecting points. If I close this window, I will see in the terminal press enter to continue. Now the frame is being loaded and segmentation will be performed. Okay, now we have to wait for a while, and here it is. Beautiful. Over here you can see several important things. First of all, these stars over here correspond to the selected points. They have precisely the coordinates that I just defined and I entered inside of this matrix over here. Then in addition to this, we are also plotting the mask. Here you can see the function being used to plot the points. This is precisely the function that's being defined over here. And in addition to that function, we are also calling the function showMask, and this function showMask will actually generate the mask of our coyote. That is, it will generate this orange or red or however you like to call this color. And this is a very important step. After that, you can see over here this message will be displayed. However, you can simply ignore this message. Now, after you close this image, you will see over here, press enter to continue, and I'm going to break the code over here such that I explain what's happening in the sequence. So let's press Ctrl+C over here to stop the code, enter and Ctrl+C. Good. Now we are here. Over here, we are running the algorithm and we propagate the algorithm throughout the video and collect the result in a dictionary. We define this dictionary containing video segments, Then over here we run propagation. Then over here we render the segmentation results every few frames. First of all, we need to define the frame stride to be equal to 1. That is, I want to run the propagation and I want to do segmentation every single frame. And over here is the part where we generate the final figures. First of all, I'm printing this message saving processed images. Then I'm defining the size of the figure that I want to save. Then I'm simply iterating through all the frames and this frame stride. I'm plotting the title of the frame. Then I'm plotting the image. Over here I'm using the mask to mask the object. And over here I save the files with an increasing index in the folder called output. That is, the images will be saved inside of this folder that we created at the beginning of this video tutorial. So again, this piece of code will render the segmentation results, it will create images, and it will save the images in the appropriate folder. Now we are ready to run everything once again, and this will be the final run. Again, let's press Ctrl-Shift-P to select interpreter, make sure that this interpreter is selected, click here to run the code, and again you'll see the first image. Here it is. Let's close the first image, let's press enter to continue. And over here the first frame with the rendered mask will be shown. Over here these stars represented the points we just selected. Let's close this frame and let's press enter to continue. You can simply ignore these user warnings since they're not important. Now we are propagating in the video, and over here magic happens. We are saving images, and not only images, we are saving images with masks. So let's see the images, where they are. They're in the output folder, and you can see how nicely images are being generated in the output folder. So here's our first image. Let's open and let's make sure it looks nice. Okay, so let me just close everything. So here's the first image. Okay, let's look into the fifth one. Here's the fifth one, looks beautiful. Here's the 10th image. Here's the 11th image. Looks perfect. You can see how nicely Coyote is being segmented, and this is truly amazing how accurately we can segment an object from a video frame. And you can see now the real-time execution of the code. This video is actually recorded with 30 frames per second. However, I downsampled this video to 15 frames per second since I don't want to have a lot of frames. I only want to have around 80 frames. So in total, I think the video length is around 5 seconds, which basically gives you around 80 frames. Now, a nice thing to observe is the resource consumption. If you open a task manager, you can see that GPU memory is being used. So you can basically click here and expand, and you can see the GPU, CPU, and other things. And you can see that CPU is also being used. However, I'm not sure if this usage is due to the Windows operating system or due to my GPU. However, you can see the GPU is working. It's not working with full capacity. However, it's still being used, which is very important. After approximately 15 minutes, images are generated. And let's inspect the output folder. In the output folder, we have in total 82 images, and every image is properly masked. For example, here's frame number 59. This number completely matches the number of total input images. The next step is to create the final video. To create the final video, that is to glue all the images, we need to go back to the output folder. And over here, we need to call ffmpeg once again. This command will create the final video. Over here, we are calling ffmpeg. We specify the frame rate. We specify the input images that are parameterized like this. We use the codec, and then we specify the rate, which will be 15 again, and this file will be output.mp4. So let's execute this, and literally in less than a second, the output is being generated. So if you now go back to the outputs folder, we will see the output video over here. Here it is, and we can nicely play it. Now, if I double click over here, you can see that media player is open, and for some reason media player is not able to play videos that are generated by using this particular codec. That is the file for creating the video. However, at the beginning of this tutorial, we explained that you should install an alternative software for generating, or basically for playing videos. The name of that software is the VLC Media Player. So let's open this file with the VLC Media Player, and here it is. This is our final video. Looks beautiful. Here it is once again. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Also, links to the manual, codes, and to the input video will be given in the description below this video tutorial.